In this lesson, we're going to look at how to find the slope of a line and how to graph parallel and perpendicular lines. How does slope apply to the steepness of roads? The grade of a road is a percent that measures the steepness of the road. It is found by dividing the amount the road rises by the corresponding horizontal distance. Rise over run sounds like slope. The slope of a line is the ratio of the change in the y-coordinates to the corresponding change in the x-coordinates. The slope measures how steep the line is. Suppose a line passes through the points x sub 1, y sub 1, and x sub 2, y sub 2. Then slope is change in y, which in science they write with a little delta, over change in x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The slope of the line is the same, no matter what 2 points are used. Find the slope of the line that passes through the point 1, and I'm going to label the second point x sub 2, y sub 2, for negative 2, negative 3, and then they want us to graph the line. Our slope formula is y sub 2 minus y sub 1, so I'm going to do negative 3 minus 3 over x sub 2 is negative 2 minus x sub 1 was 1. So negative 3 minus 3 is negative 6. Negative 2 minus 1 is negative 3. So our slope, negative divided by negative, is positive. 6 divided by 3 is 2. The directions said then graph the line. If we would have graphed the line first, it would have been kind of handy because then we could have just counted squares and got the slope that way. Because you can see it's going up 2 over 1, up 2 over 1. This one's lovely because they just want us to graph the line through the point 1, negative 3 with a slope of negative 3/4. So we just need to plot a point at 1, negative 3, and then from there we're going down 3 over 4, and we could keep going on forever, down 3 over 4. Or if we had to go backwards because your piece of graph paper didn't fit it right, you could go up 3 and backwards 4. We've done that before. If a line rises from the left to the right, its slope is positive. If it's horizontal, its slope is 0. I'm not going up or down. If it falls from left to right, then the slope is negative. A vertical line, the slope is undefined. Slope is often referred to as the rate of change. It measures how much a quantity changes on average relative to the change in another quantity, most often time. Looking at the graph, they want us to find the rate of change of the number of radio stations on the air in the United States from 1990 to 1998. So in general sense, rate of change is amount change divided by time. They were nice and they labeled the points they wanted for us, so we didn't even have to read them from the graph and guesstimate. And the amount of time, we're going to go 98 and 90. So the difference is going to be 1.8 and 8, and the quotient is 0.225. If we look up and read the chart, we can see that's in thousands. So if we take that number times 1,000, that's handy. Just move our decimal 3 places. And we're going to get 225 stations per year. A family of graphs is a group of graphs that displays one or more similar characteristics. The parent graph is the simplest of the graphs in a family. A graphing calculator or GeoGebra can be used to graph several graphs in a family of graphs on the same screen and see common characteristics. The first family of graphs we're going to look at is parallel lines. In a plane, non-vertical lines with the same slope are all parallel. All vertical lines are parallel. And of course, all horizontal lines are parallel because they all have a slope of 0. They didn't bring up horizontal specifically there because they have a slope. It's the same at 0. Graph the line through the point 1, negative 2 that's parallel to the line with the equation x minus y equals negative 2. Okay, there's a couple ways we could handle it. we could find the slope of our new line and just do it all algebraically, then graph it. So to find the slope, we'd subtract x from both sides and divide by -1. So y equals 1x plus 2. Okay, so our original slope is 1. We could have also just found the x and y intercepts. If we let x be 0, we can find the y-intercept. So we're going to have y equals 2 when x is 0. And if we let y be 0, we can get the x-intercept. So now we're going to have a nice point x equals -2, so that's going to be easy to graph as well. Using my first method, I'd have a y-intercept of 2, a slope of 1, so I'd start at 2, go up 1 over 1. Using my second method, I have a y-intercept of 2 and an x-intercept of -2. You plot those 2 points, draw the line. Any which way I can see my line is going up 1 over 1. So my new point is 1, -2, so 1 to the right, 2 down, and from there we're going up 1 over 1 as many times as you like to draw a nice straight line. We can also look at lines that are perpendicular, so they cross it to form right angles. In a plane, 2 oblique lines are perpendicular if and only if their product of their slopes is -1. So suppose m sub 1 and m sub 2 are the slopes of 2 oblique lines, then the lines are perpendicular if and only if m sub 1 times m sub 2 is -1, or m sub 1 equals, this is the one I usually use, the opposite of the reciprocal of m sub 2. And of course, any vertical line is perpendicular to any horizontal line. And in case you didn't remember what an oblique line is, it's just a line that's neither horizontal nor vertical. I want us to graph a line through the point 2, 1 that's perpendicular to the line with the equation of 2x minus 3y equals 3. Okay, this one's not going to have nice integer x and y intercepts, so I think I'm just going to do this one algebraically. So we want to solve for y. Subtract 2x from both sides. So -3y equals 3 minus 2x. Divide by -3. So y equals -1 plus 2/3 x. So if my original slope, I'm calling that m sub 1, is 2/3, then the slope of the line perpendicular to that is going to be -3 over 2. If it makes you happier, I could rewrite this in our normal y equals mx plus b form. That's probably bothering someone. So we would start the graph at, our y-intercept is -1, and from there we're going to go up 2 over 3. I don't know why they put a point there. That's awkward. It's easier to do integers. Why not? Up 2 over 3. Nice integer points. All right. So our new line has to go through the point 2, 1. So 2 to the right, 1 up. And it's going to go down 3 over 2. So from 2, 1, we're going down 3 over 2. They used integers that time. That was nice. The slope of the line is the ratio in the change in the y coordinates to the corresponding change in x coordinates. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is our slope formula. Lines with the same slope are parallel. Lines with slopes that are opposite reciprocals are perpendicular.